Hello everyone. In this video we will learn scientific notation. Okay, let's start. What is scientific notation? Scientific notation is a standard way for representing numbers in science. For example, based on the measurements, speed of light is this value in meters per second, or hydrogen atom has the radius of this. As you see, these numbers are really bizarre and they are not easy to understand. Scientific notation helps you to make them concise and understandable. Let's have a review on a structure of a number. A number is made of digits and number places. Suppose that these are number places and I have decimal point here. On the left side of the decimal point, I will have number place of ones, number place of tens, number place of hundreds, and also on the right side, I will have tenths, I will have hundreds, and I will have thousands. The number places could be occupied by digits. Any arbitrary digit can occupy one of them. How to move the decimal point? This is a given number with a decimal point here. Basically, I can put a 10 to 0 on the right side of this number with no effect on the size. 10 to 0 is 1. Now I move the decimal point one step forward. If I do that, I should decrease the exponent by 1. Likewise, if I take the decimal point one step leftward, I should increase the exponent by 1. Let's move the decimal point in this example. This is a 4-digit number and the last right digit is 2. By default, I can put a decimal point on the right side. And if I displace that decimal point one step to the left, the exponent will be 1. And if I do that again, it will be 10 to 2. If I do that again, it will be 10 to 3. Pay attention, in all versions of the original number, all the digits will keep the same position, will keep the same number place. For example, in the original number, 2 as the last right digit is in the order of ones. This is the same in all the other versions. But pay attention, the last version is something we are looking for. This is scientific notation. Let's introduce the scientific notation. Suppose that this is a given number, which could be, for example, the length of an object, 243. By default, I can put a decimal point on the right side after the last right digit. If I take it 2 steps leftward, I will increase the exponent by 2. So it will be 2.43, 10 to 2. This is the standard scientific notation. It has 3 distinguished parts. First is the coefficient, which is a number between 1 and 10. The other is the base, which is 10. And the last part is 2, exponent. Exponent sometimes is named order of magnitude. Pay attention. Don't change the number of significant figures. I have a video about significant figures, please check that. And if you know them, I can start. This is 4,000, a given number. It has just one significant figure because the trailing zeros are not regarded as significant ones because there is no decimal point. If I manually add one decimal point here, it can't change the number of significant figures. So if I put the decimal point 3 steps leftward, I should have 4 times 10 to 3. 4 times 10 to 3 also has just one significant figure, and the trailing zeros are removed. On the other hand, if the given number is 4,000 with a decimal point, so it has 4 significant figures, and the answer will be 4.00010 to 3. It has also 4 significant figures, so pay attention. You are not allowed to change the total number of significant figures when you convert a number to scientific notation. Let's consider some examples. Convert to scientific notation. Suppose that the given quantity is this. I'm going to have scientific notation of that. I should displace the decimal point 2 steps to the right to make the coefficient as a number between 1 and 10. So it's 5.520, 10 to negative 2. As you see, the number of significant figures, the original number is 1, 2, 3, 4. Here I have also 4 significant figures. In the scientific notation, I have not changed the number of significant figures. As you know, the first two zeros are leading zeros and they are not significant. The other example could be 200,000 with no decimal point on the right side. So it has just one significant figure and all the zeros could be removed. And so I will have 2 10 to 5 as I put manually a decimal point here and I've displaced that 5 steps to the left. So it will be 10 to 5. Very similar example could be 200,000 with a decimal point. As you see, all the trailing zeros in this case are regarded as significant ones. So it has 6 significant figures, 1, 2, 3, 4, 5, and 6. So I will keep the whole number like this, 2.00000, 10 to 5. Pay attention to the similarities and differences between these two examples. The last case will be 63,000,1. All the zeros in between are significant figures, and so I should put a decimal point here and displace it 1, 2, 3, 4, 5 steps to the left, so the exponent will be increased by 5, and the answer is 6.300001, 10 to 5. I hope you enjoyed this video. Don't forget to push the like button and subscribe.